Welcome to our presentation on N-Acetylcysteine, NAC, in medicine. We will explore 3 decades of research, focusing on its history, biological mechanisms, and clinical applications. N-Acetylcysteine, NAC, originated as a treatment for acetaminophen poisoning in the 1970s to 80s. It acts as a precursor to cysteine and glutathione, crucial for the body's antioxidant system. NAC's core mechanisms include modulating redox homeostasis, regulating the glutamatergic system, supporting mitochondrial function, and exhibiting anti-inflammatory activity. NAC restores the GSH/GSSG balance by providing cysteine, crucial for glutathione synthesis. It activates NGLUR2/3 receptors, reducing excitotoxicity. NAC also decreases oxidative stress in mitochondria, enhancing ATP production. Additionally, it inhibits NF-Kappa B activation, lowering pro-inflammatory cytokines like TNF-alpha, IL-6, and IL-1 beta. In neurological applications, NAC reduces irritability in autism spectrum disorders through redox regulation. It offers dopaminergic protection in Parkinson's disease, reduces neuroinflammation, and protects myelin in multiple sclerosis, and provides neuroprotection in stroke and traumatic brain injury by stabilizing mitochondria. In psychiatric applications, mood stabilization in bipolar disorder and depression is achieved through glutamate modulation and inflammation reduction. Obsessive-compulsive disorder symptoms are alleviated by activating metabotropic glutamate receptor 2/3 receptors. For addictions and trichotillomania, dopaminergic transmission modulation helps reduce cravings and repetitive behaviors.
In renal applications, it prevents acute kidney injury from iodinated contrast agents and slows chronic kidney failure progression. It also reduces inflammation in glomerulonephritis. For cardiac protection, it reduces ischemia-reperfusion injury, improves systolic function in heart failure, and acts as an antiarrhythmic by modulating sympathetic tone. In pulmonary disorders, N-acetylcysteine slows idiopathic pulmonary fibrosis progression, reduces chronic obstructive pulmonary disease exacerbations, and acts as a mucolytic and anti-inflammatory in asthma and bronchiectasis. For gastrointestinal disorders, it protects the mucosal barrier in inflammatory bowel disease, Crohn's, and colitis, modulates visceral pain in irritable bowel syndrome, and prevents nonsteroidal anti-inflammatory drug-induced ulcers. NAC is the recommended antidote for acetaminophen poisoning, with optimal effectiveness within 16 to 24 hours post-ingestion. It works by conjugating the toxic metabolite NAPQI and replenishing hepatic glutathione. Additionally, NAC serves as a chelating agent for heavy metals like lead, mercury, cadmium, and copper in both chronic and acute exposures. NAC is available in oral, intravenous, and inhalatory forms. Oral bioavailability is 5 to 10%, while intravenous administration achieves higher plasma concentrations with a half-life of 30 minutes. Clinical dosages vary: 150 milligrams per kilogram intravenous. For acetaminophen poisoning, 1,000 to 2,000 milligrams per day for psychiatric disorders, and 600 milligrams twice or thrice daily for pulmonary diseases. NAC boasts an excellent safety profile with no dependence or chronic toxicity, even at high doses. Gastrointestinal effects like nausea and vomiting occur mainly at higher doses. Cutaneous reactions such as rash are uncommon, while central nervous system effects like headache are rare. Anaphylaxis is extremely rare, primarily linked to rapid intravenous administration. NAC shows strong clinical evidence in 5 key areas: acetaminophen antidote, psychiatric and neurological disorders, contrast nephropathy, and chronic obstructive pulmonary disease with fibrosis. Acetaminophen poisoning remains the only fully approved indication. Current studies focus on optimal dosing, patient stratification, and synergistic combinations. NAC demonstrates a broad therapeutic spectrum with mechanisms like redox regulation and inflammation inhibition. It is safe for chronic use, including in pediatric patients. Precision medicine highlights cysteine/glutathione deficiency as a treatable cofactor. Future research will focus on optimal dosing and synergistic combinations.